This is Unit 15. It is titled Redox. Not Reeboks, Redox. Redox is short for reduction and oxidation. Now, in my chem class or in my AP Bio classes, we're getting ready for the AP Bio exam, and I've been telling them several times throughout the exam. There are some questions that you certainly would need some background in chemistry. Unfortunately, it's not mandatory that you take chem before AP Bio, but I've been saying a lot. This is when we get to one of those questions that's more chemistry based. I say, this is why I think AP Bio students should have taken chem. And several of the questions that have come up during my AP Bio exam review have had the words oxidation and reduction. In my AP Bio classes, I have some sophomores. They have no idea what oxidation reduction is because typically sophomore year you take chem. But for those juniors and seniors, they know it. So this is going to be some important stuff. It is a pretty quick unit, but I do want to emphasize that reduction and oxidation are going to be very important phenomena, okay? So let's recap, first off, the 5 types of chemical reaction classification. All right. First one is a synthesis reaction. This is simple where A plus A and B react to yield AB. 2 is the opposite of synthesis. It is called decomposition. AB breaks down to A and B. Number 3 is a single replacement reaction. There's a few ways you could write this down. You can say AX plus B yields BX plus A, but that's the main one. The 4th one is a double replacement reaction. AX plus BY plus BX plus AY. And then number 5 is a, what is it? You recall? Combustion. Where you basically have a carbon molecule, or excuse me, a carbon atom bonded to something random. X is a variable. Plus O2 yields CO2 plus H2O. It doesn't matter what X is, but carbon needs to be bonded to it. All right, now here's the point. All 5 of these involve the transfer of electrons. It's probably going to have hydrogen, or it's likely going to be a hydrogen molecule, but I can't indicate how many. So X is typically going to be hydrogen. But that's not the point. The point is that all 5 of these involve the transfer of electrons. The symbol for electrons is an E with a superscript negative symbol. I want to reiterate to all of you what an electron is. So we learned this back in Unit 2, which is like September. What is the charge of an electron? Negative charge. Its mass is negligible, which means it's practically not even there. It's 0.0005 atomic mass units. Very, very small. Where are they found in an atom? Are they in the nucleus or are they orbiting the nucleus? They orbit the nucleus. They're found in the electron cloud. So imagine that you were to receive a handful of electrons. Would you have become more negative or more positive? Keep that in mind. Whenever a given element or molecule or compound receives electrons, it is becoming more negative. Keep that in mind. So let's do a few examples of electron transfers. I'll explain to you guys what the words oxidation and reduction mean. That's all part of the plan today. So let's say that we have what we call a complete chemical equation. For the synthesis of sodium chloride. Two sodiums react with chlorine gas to yield 2 sodium chlorides. Very basic synthesis equation. But if we were to do the net ionic equation, I want you guys to notice something here. This sodium here is neutral. This chlorine gas is neutral. How in the world does sodium chloride come to be if they're both neutral? Well, when you bring them together, they will have a charge, and they have opposite charges. Sodium has a positive charge. Chloride has a negative charge. They're going to balance each other out by attracting each other. So this is known as a net ionic equation. Your reactant side stays the same. But what I want you to do is I want you to separate the sodium chloride into its ions. The only way that sodium chloride in ACl can actually form is that you have to have opposites attract to form an ionic bond. So there's 2 sodium ions there. We're going to say 2 sodium ions. And there's 2 chloride ions. We're going to say 2 chloride ions. A lot of this is review from the first semester. Right now is probably clear as mud. You don't know what the heck is happening. So let's break this down even further. Let's think back to, what was it, Unit 5? How many total electrons does sodium have? In order to answer that question, you need to look at the atomic number. The atomic number tells you the number of protons. If it has that number of protons, it has the equal number of electrons. So how many electrons does it have? 11. How many electrons can it fit on its first energy level? 2. 1, 2. How many can it fit on its second energy level? 8. 1, 2, 3, 4, 5, 6, 7, 8. How many do we have so far? We have 10. So we have to move on to a third level. How many does it have on this third level? 1. This is a total of 11 electrons. Is sodium stable? Sodium is not stable. Why is it not stable? I know this is not an AP class, but if you were to take an AP class, you can't just say, no, it's not. You have to justify. Justify means explain yourself. Kevin? It does not have 8 electrons on its outermost shell. It only has 1 electron on its outermost shell. So a common question I asked you back in Unit 5 is, what would it be easier for sodium to do? Gain 7 more to complete its third level, or lose that 1 on its third level to drop down to the second level, which is already stable? Lose 1, and it will become stable. So let's lose it. I'm going to just put this over here for safekeeping. I'm going to erase all this. And so now, how many electrons does it have? 10. But how many protons does it have? 11. So what is its ionic charge? Is it positive or negative? By how much? From here on out, I don't want you guys to just say positive or negative. I need you to say +1 or -3 or +2. There's one more proton than there is electron. That means it's positive by 1. So this is now a sodium ion. It is a +1 charge. Let's take a look over at chlorine, the other half of sodium chloride. What is the atomic number of chlorine? 17. So if it's 17 protons, how many electrons is it? 17. Okay, let's draw it out. How many electrons go on the first shell? 2. How many on the second shell? 1, 2, 3, 4, 5, 6, 7, 8. How many are we up to? We're up to 10. So how many will go on the third level? 7. 1, 2, 3, 4, 5, 6, 7. Is chlorine stable? No, it isn't. Why is it not stable? It needs to have 8 on its outermost energy level. It does not have 8, it has 7. So it is starving for one more. Where do you think it's going to get it? From sodium. There it is. How many electrons does does chlorine have now? It has 18 electrons. What is its ionic charge? It has 17 protons, 18 electrons. -1. Does positive attract negative? Yes. So these two are going to really get close. And they're going to form an ionic compound. Positive will be attracted to negative. Now, here's the next important thing I'd like to ask you. At what ratio does sodium and chloride neutralize each other or cancel each other out? You have +1, you have -1. At what ratio will they balance each other out? 1-to-1 ratio. So it's going to be 1 sodium, 1 chloride. That is all stuff that you've done before. Here's the new thing. Oxidation and reduction. The term oxidation means electrons lost. You could use multiple words for lost. You could also use donated. You could use given. Whatever the terms you want to say. I don't care if you donate your shoes, you lost your shoes, someone stole your shoes. Point is, you don't have your shoes anymore. That's the point. If anything in chemistry has been oxidized, it has released its electrons. Its electrons were donated. Its electrons were taken. However you want to phrase it, I don't care what verb you use. The point is, if sodium gave up an electron, it doesn't have it anymore. That's the point. So in this case, sodium was oxidized. It lost an electron. Now, the opposite of oxidation is reduction. Now, I remember learning this in chemistry, and this always blew my mind because I thought, okay, if you are being reduced, that means things are being taken from you. It doesn't make sense that if something is reduced, electrons are added. That makes no sense. Here's why it makes sense. What is the charge of an electron? If you're receiving more electrons, is your charge going up or going down? It goes down. Let's sink in. Another word for going down is reduced. I went to Walmart. Price went down for a pair of socks. Another way you can phrase that is the price was reduced. If my phone, Max, you better catch this, is an electron. Max just received an electron. Did his overall charge go up or go down? He just gained electrons, Derek. What is the charge of electrons? Oh, that's the best sound a teacher can ever hear. Oh, I hope that means you understand. So, Max, throw it back to me. You better not break it. He just gave up an electron. What happened to him? What's that term? It was oxidized. I just took that electron. What happened to me? I was reduced. You can't have one without the other. It's the yin and the yang. It has, if your mom gives you $20 for gas, you just became $20 richer. What happened to your mom? She's $20 poor. So you can't have one without the other. The Bucks won the Super Bowl. Woohoo! You can't have that happen unless the Chiefs lost. You have to look at it both ways. And by the way, Rays swept the Yankees this weekend. Rays can't sweep the Yankees unless the Yankees got swept. Brought my broom. Any Yankees fans in here? Good answer. All right, let's keep going. So take a look at magnesium oxide. I want you guys to break that up into its ions. I want you to identify what got oxidized, what got reduced, and how it happened. Arshawn, don't shout at. Who was? What? Here we go. All right. What would the charge of magnesium be? What would the charge of the oxygen be? Let's figure out how it got to be that way. Let's look at magnesium first. Magnesium atom. When I say atom, that means it's neutral. How many protons does it have? 12 protons. So how many electrons does it have? All right, let's draw it out. 2 electrons on the first shell. 8 electrons on the second shell. 2 electrons on the third shell. Clearly not stable. It only has 2 on the outer shell and it needs 8. So what would be easier for magnesium to do? Gain 6 more to stabilize its third energy level, or lose those 2 to be dropped down to its already stable second level? Lose 2. So we are going, I'm just going to lasso these little guys right there. Bring them over here for safekeeping. Oh, come on. Come on. There we go. And this is now gone. Okay, so it just lost 2 electrons. So what is its new proton number? The proton number, trick question, the proton number didn't change. It's 12. What is the new electron number? 10. So what is the charge of a magnesium ion? Positive 2. Okay, and the other element is oxygen. Let's take a look at O. How many protons does it have? 16. How many electrons does it have? Oh yeah, I don't know why I thought 16. I'm thinking O2. Excuse me. Just 8. How many protons does it have? 8. Okay. So let's draw that out. Two on the first energy level. 1, 2, 3, 4, 5, 6. 6 on the second energy level for a total of 8. Oxygen is not stable. It has 6 valence electrons. It needs 8. What would be easier for oxygen to do? Gain 2 more to stabilize its valence shell, or to lose 6 to go down a level? Gain 2. Where's it going to find them? The ones that magnesium had. Here they go. So oxygen no longer has 8 electrons. How many does it have? It has 10. So what is its ionic charge? -2. At what ratio will a magnesium ion and an oxide ion balance each other out? If they're +2 to -2. 1 to 1. That's why it is a 1 to 1 ratio, everybody. Which element was oxidized? Derek.
Magnesium.
Explain yourself. Justify yourself.
So it donated to oxygen, and since it donated 2 to oxygen gained 2, but since the electrons are negative, it lost two. So it's
No, 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 no. You're thinking that wrong. You were good up to the point. You said oxygen gained 2. Think about oxygen's overall charge. It went from -8 to -10
Yes.
for electrons. So its overall charge went down from 0 to negative. It was neutral. Now it's going from 0 to -2.
Yeah, so it was reduced.
It was reduced. It didn't lose anything. It gained electrons, but its charge went down. Its charge was decreased. Its charge went down. That's why we call it reduction, because its charge went down. I've been asking my AP students that a lot. Why do we call it reduction? Because the charge is decreased. Another word for decreased is reduced. Okay? So here is, let's go back to your sodium example. Here's how oxidation actually works. This is going to be pretty important. It is defined as electron or electrons being lost. If we have sodium, I want you guys to look at how I just wrote it. Is that a sodium ion or is that a sodium atom? How can you tell it's an atom? What is the difference between a sodium atom and a sodium ion? Okay, so what we could do is say that a sodium, in order for a sodium atom to become an ion, you need to add an electron to it. Key thing when you're identifying an oxidation reaction, electrons are products. When something is a product, that means it's being lost. In a few weeks, Plain High School will graduate its seniors. The seniors are gone. You can kind of look at that like Plain High School is losing its seniors. Are the seniors considered a product of Plain High School, or are they considered a reactant to Plain High School? They're a product. They're gone. They're leaving. Bye-bye. Their history. This electron is being lost. If something's being lost, if it's moving on to bigger and better things, that's known as a product. And by definition, oxidation is the losing, the donation, whatever verb you want to say, it's the bye, see ya of electrons. They're gone. So they're going to be a product. When it comes to reduction, if you take a look at chlorine gas, if you have regular old chlorine plus 2 electrons, you're going to get 2 chloride ions. Right here, they're gained. In the August, Plain High School is probably going to gain a few hundred freshmen. That's going into Plain High School. It's going in. So we consider that a reactant. When it comes to reduction reactions, electrons are reactants. Later in this unit, when you guys are writing your individual oxidation and reduction reactions, this is going to be very helpful. I'm going to just try to drill it into your head every day. Electrons are gained. When Plain High School gains freshmen, they're being added to it. When your house is receiving groceries from Publix, the groceries being added to your house. It's really that simple. So it's a reactant. When you sit on the toilet and go boom, boom, it's leaving. That's a product. It's out. Oxidation cannot happen without reduction. Reduction cannot happen without oxidation. Oxidation and reduction are complementary processes. Why is it called reduction? Tell me one more time. Even though you're gaining electrons, you have to remember it's the electrons that you're gaining. Your charge is going down. Okay, let's talk about oxidation numbers. What time is this class over? 10:45. What time is it? Oh, we have plenty of time. All right, next topic. What are oxidation numbers and how to identify them? It's pretty simple. The oxidation number can be identified by referring to an element's grouping. Group 1 has a positive 1 charge. If I were to go to group 17, it would have a negative 1 charge. It's the same way you guys figure out the ionic charges. So if I were to actually draw a periodic table, okay, more often than not, there are some exceptions, and we'll go over all those exceptions a little bit later. But for more or less, if you want to know the oxidation number of an element, it's going to be basically the same thing as ionic charge. So do you recall what is the charge of everything in group 1? So that's going to be its oxidation number as well. How about group 2? How about group 3 or 13? How about group 14? Sometimes the bond is it's -5, but we'll go with it's weird. But more at the top is +4. How about group 15? -3. Group 16? -2. Group 17. Very good. So more often than not, if you want to know the oxidation number of an element, it's going to be the same as its ionic charge. Now there are a few exceptions, and I will get to those in time. I don't think I'm going to get to them today, but we'll go over all those exceptions later. But if you wanted to look up something, find its oxidation number, you look and see where it's located, and you have to find its charge. So let's just do a few examples for me. I want you to find the oxidation numbers for the following elements. Please find the oxidation numbers of those elements. I should see a lot of looking at the periodic table. What is the oxidation number of magnesium? Aluminum, potassium, fluorine, oxygen, phosphorus. It's that simple, guys. All you have to do is find it in the periodic table and identify the column it's in. Any questions so far? All right. Next, I'd like to talk about oxidizing and reducing agents. Okay, I am a burglar. I I just stole Jade's pencil bag. I am the burglar. What would you call her? She's burgled. It's a weird word. She just got burgled. Who burgled her? I did. Now imagine this is an electron, okay? This pencil bag is an electron. Right now, I take her electron. What happened to her?
She got burgled.
She was oxidized. Who oxidized her? There's the difference I'm trying to convey to you. What I am called is the oxidizing agent. She got oxidized, but I'm the one that oxidized her. That makes me the oxidizing agent. Now, on the other hand, I have this electron now. What happened to me? I was reduced. Who's responsible for that? Jade is. So what would we call her? She's the reducer. Yeah. We call that the reducing agent. If you go to the lunch line today, you get your lunch, you get served food. You just got served. Who served you? The lunch lady. So what I'm trying to convey to you guys is there's a difference between the server and the servee. There's a difference between the burglar and the burgled. There's differences here. You could pet your dog's getting pet. Well, why is that? Because you're petting them. So these are oxidizing and reducing agents. Let's take a look at this equation to explain this phenomenon. We have 2 atoms of potassium react with 1 molecule of chlorine gas to yield 2 compounds of, or 2 moles of potassium chloride, KCl. Potassium is a cation. It's in group 1. It has 19 protons. Here's why I want you guys to get better at. This is going to make your lives so much easier if you can just figure this out. Right here, potassium has 19 electrons. In order for it to bond with chloride, how many electrons did it lose? It's in group 1. So what is this electron count now? 18 electrons. Chloride, each chloride has, I'm looking at the periodic table, 17 electrons. In order for it to bond with chloride, how many electrons must it have? 19. 18, you're right, excuse me. I was wrong. And so now they're both balanced. But what I want to convey to you here is that the electrons from potassium went to chloride. Potassium lost 1 electron each. Chlorine accepted 1 electron each. Yes, Carson?
This is 2 potassium. Why don't we make it like 38 electrons?
Because there's 2 separate potassiums, 1 each. There's 2 separate potassium atoms. It's not K2, it's 2K.
So what? Cl2?
Cl2 is diatomic. I'm saying 1 individual chloride ion. There's 2 chlorides, there's 2 potassiums. It looks like this, guys. I see where your confusion is. Here's potassium. Are those separate or are those together? Those are separate. Here's chloride. That's a molecule. Are they together? Yes. And when you actually have the compound, KCl, it looks like this. It's just rearranged. I'm just going based on one of these, just focus on one of those, and then try to get focus on one of those. Okay? So each chloride has 17 electrons. It needs to gain 1 more to get up to 18 to be stable. Potassium has 1 extra electron. It needs to lose 1 to get back down to 18 to be stable. Because chloride, and this is going to be something else that's going to be some foundational knowledge. the cation always is oxidized. So what you need to be able to do is identify what is going to be positively charged, what's going to be negatively charged. Remember that the only way that something can be positively charged is if it lost electrons. So here's potassium. I can break it down for you. If I look at the periodic table, potassium has 19 protons, 19 electrons. But because it is found in group 1 on the periodic table, what is its ionic charge? Positive 1. Well, does the proton number change? No. So that's 19 protons. Its positive 1 charge means that it has one more proton than electrons. So what is its electron number? Only a few people said that. This is always something pretty tricky for your brains to try to grasp. I want you to repeat after me. The proton number does not change. So if the proton number doesn't change and its charge is positive 1, what must the electron number be? 18. It went down 1. So did potassium lose an electron or gain an electron? An electron was lost. This is what oxidation is all about. Well, you can't have one without the other. Let's look at chloride and chlorine. Chlorine is 17 protons, 17 electrons. I look at the periodic table, I see chlorine is found in group 17. Because it is found in group 17, what is its ionic charge? Negative 1. Does the proton number change? No. So the number for protons is still 17. If its charge is negative 1, did it gain 1 electron or lose 1 electron? So what is this new electron number? Where did it get that electron from? The potassium. It got exchanged, okay? So here's what we're saying. In order for potassium to join potassium chloride, did potassium get oxidized or reduced? It was oxidized. And how about chlorine? Okay. Potassium was oxidized. I think we're all clear on that. What oxidized it? What took its electron away? Chlorine took it. So what does that make chlorine? Chlorine is the oxidizing agent. You can think of it like that. Okay? Chlorine was reduced. That means it gained an electron. Who reduced it? Potassium reduced it. Okay. I think I want to stop there. We have 3 minutes left, and I do not want to get into a new topic. We'll stop there. You guys will have a homework assignment tomorrow. I'm going to give you tonight off. But tomorrow you're going to have one on redox reactions.